Hello guys, welcome back to another AIME problem solution video. Today we have yet another question here, and as always, let's first start off by reading the question. So, in an equiangular octagon Caroline, CA is going to equal to RO equal to LI equal to NE, which is going to equal to square root 2. And AR is going to equal to OL equal to IN equal to EC, which is going to be equal to 1. Now, the self-intersecting octagon Cornelia encloses 6 non-overlapping triangular regions. Now, let K be the area enclosed by Cornelia, that is, the total area of the 6 triangular regions. Then K is going to equal to A over B, where A and B are relatively prime positive integers. So find A plus B. Now, our first step for this problem is to first be graphing what Caroline looks like in Cornelia. Now, in order to save some time, I've already pre-done this for you guys, and I'll go over on how I did this. Now, because we know that AR, OL, IN, EC is going to equal to 1, and the other sides are going to equal to square root 2, I can sort of just write a 3 by 3 square with an octagon in the middle. So as you can see here, we have Caroline, like an octagon shape, with OL here being 1, AR equal to 1, and RO here equaling to square root 2 and being on the same for all the sides. Now this means that Cornelia, which you can kind of trace with your hands, so we start at C, C-O-R-N-E-I-L, I said that wrong, sorry, C-O-R-N-E-L-I-A. As you can see, when you trace it, it sort of encloses these 6 triangles that I've shaded in for gray. Now I've also decided to add a couple of new points of my own, these being X, Y, Z, Q, and W. Now I haven't added these points for the other side, as it can kind of just be flipped over. Now we need to find the value of K, which is just the area of Cornelia, and this is going to equal to, so I'll write it down, K is going to equal to 4 times the area of ACY plus 2 times the area of YZW. So YZW is this smaller triangle here, and ACY would be one of these big ones. So there's 4 of these that are all congruent, and there are 2 of these smaller ones here, which is YZW. So let's first start off by looking at some similar triangles between ARW and YZW. Now we can see here that since they both have the same angles, we can know that they are similar triangles. And now we'll create a ratio based on them. So I'll write this down. So ARW is going to be similar to YZW. And the ratio between them is going to be 3 to 1. And how do I know this? Well, I'll tell you in a second. Now, the reason why I know that the ratio between them is 3 to 1 is mainly by looking at their heights. Now, we can see that the height for YZW is pretty simple. It is half of this side length here, 1, which means the height of YZW is going to be 0.5. And the height of ARW is 1 plus 0.5, which is 1.5. So the ratio should be 3 to 1, or if you want to write like the original, it would be 1.5 to 0.5. All of these are the same, so I just wrote 3 to 1 for simplicity's sake. Now with this, because we know the base of AR is going to be 1, we know that YZ is going to have to be equal to 3 over 1 multiplied by the base, which the base of the other triangle, which is AR, which is equal to 1. So I'll just write that down here. And this is obviously going to be equal to 3 over 1. This is obviously going to be equal to 1 over 3. Sorry. And because we already know that the height of YZW has to be 0.5, we can tell that the area of YZW in total should be, I'll just write this down here, YZW is going to equal to 1/3 multiplied by 1/2 multiplied by 1/2 again because it's a triangle, which is going to equal to 1 over 12. Now let's solve for ACW. Now ACW is going to be a lot easier, as you now know that what YZ is. Now let's look at X to Q. Now we know that X to Q is going to equal to A to R, which is 1. And since you know that XY and ZQ are going to be the same, since all of these 4 triangles here, like the bigger ones, are congruent, we know that XY and ZQ are going to be the same. We can tell that, so I'll write this down actually, XY is going to equal to ZQ, and this should equal to 1/2 of 1 minus YZ. And since YZ is equal to 1 over 3, this is going to equal to 1/2 of 2 over 3, which is 1 over 3. Pretty simple, right? And this means that cy has to be cx plus xy. Since we know that since we know what xy is equal to, which is 1 over 3 or 1/3, we know that cy has to be 1 plus 1/3. So cy is going to equal to 4 over 3. And now the height is pretty simple. The height is going to be ax, which is equal to 1. And it's the triangle, we have to divide by 2, which means that the area of ACY is going to be equal to 4 over 3 multiplied by 1, which is the height. Now you can write that, but I'm writing it down so you guys know. Multiplied by 1 over 2, which is going to be equal to 2 over 3. And this means that the area of K, following back to this formula, should be, so I write K again, K is going to equal to 4 multiplied by ACY, which is 2 over 3, plus 2 multiplied by 1 over 12. And now we can simplify this into 8 over 3 plus 25 over 12. And you can further simplify this into our final answer, which is 17 over 16. Sorry, 17 over 6. You guys can do the rest of the stuff in between, but I decided to skip to here to save some time. Which means that the final answer, which is a plus b, should be 17 plus 6, which is equal to 23. So the answer to this problem should be 23. Thank you guys for listening. If you have any other way to solve this problem, please let me know down in the comments, and thank you guys for listening. Bye.